Check 1, 2, check 1, 2. Lead tech service went live. I am doing a water damage recovery on a iPhone 6. Pretty sure it's just a 5-volt capacitor next to the Wi-Fi. Only component that's really water damaged on this thing. We're going to clean it up and replace it and see how it goes. We pop over to Pads, which is a free software where we can view schematics. What we would find in here is that component here, and we can see all the components that it's actually connected to. I'm not going to power test the board because it does have water damage to it, and I don't want to burn anything else, especially the Wi-Fi because it's not fun to replace. If we take that information and go into the electrical schematic, we might be able to find out what or where to replace this guy from. I'm using a donor board for this one, but if you had capacitors on hand, you would want to use one of those. So it looks like C5202 RF, really common capacitor to go bad. If you have a water damage board, you might want to check this guy first. So, do a little search here. This is it. It is a Wi-Fi Bluetooth cap on VCC Main. VCC Main, if you have a shorted cap to ground, is going to take this whole rail, which is supposed to be 4 point something, and you'll have 0 volts out of that 4-volt rail. This is a 10 microfarad cap, up to 6.3 volts in a 0402 package. This is what's known as a common cap, and you can find these pretty well anywhere on most phones. If we take some of this information and plug it in here, let's see. See if we can come up with anything. So, not what we're looking for. So, let's type 10 right. Okay, there's one. So, as you can see, these are really common, and you can find them throughout the board. I'm going to use another iPhone 6 Plus, which is pretty identical. This is iCloud lock, probably. I have a few bins of different known good working ones, 6 through the 7 Plus. I think there's some 5S, 5C, SC in here too. And components are used throughout most devices. Okay, so we know what we have, we know what we're looking for. I'm going to turn on my equipment and get started. I use a AUO 738H. It's like $150-ish on Amazon, and a $150-something microscope. I will be upgrading soon, but for now, we're gonna make do. So I'm getting it started. I enjoy the music, and if you want to talk, pop up in the group chat, and I will respond. There's going to be a lot of chatter because I have a air extractor right here. It is literally the case fan out of a iMac, and it puts out a good amount of air, so it helps me out, keeps smoke out of my face. If you have the resources to buy a Rabbit Air, do that. I had one in my last shop and it's pretty damn good. Also, if you have the resources to buy a ultrasonic cleaner with a sweeping frequency, also do that. But I will use a toothbrush and rubbing alcohol because, again, we're making do. That good clean. There's a lot of black residue on there. We want to get as much of that off as possible. And there's also some sealant around the Wi-Fi module, which doesn't help us out any. So one thing we can do to test this capacitor to see if it is actually bad is see if it does in fact have a path to ground. Good old multimeter. It is a 130S multimeter. The only important part is that it has a function, diode mode, that it will beep when you touch these together. You have that, you're basically all set. Maybe one that has voltage out is helpful to you. We have a path to ground through both sides. This side is my ground. I'm going to touch it to a shield, top of the shield, and this one I can put to the ground side, and this one I can put to the not so ground side, and it's officially grounded, so it has to go. And always turn off the multimeter, or to make it sad, batteries will go dead. So that cleaned and tested. I'm going to set my hot air to super low, maybe 100, 170, because, yeah, again, you don't want to melt the Wi-Fi. If you overheat him, he won't be happy. I'm going to zoom back into what we're working on, so anybody coming in might be able to see. So here we go. I'm not sure if you guys are going to be able to see this, but there are tiny, tiny components in this area that when you're scraping off this black stuff, just make sure you don't knock those off. They're fun to put back in place. What I'm doing is I'm just moving the stand around to be able to get better access to where I need to go. It's a lot easier to move your hand than, it's a lot easier to move your board than try to contort your hand and be uncomfortable. One really important thing is that you be really comfortable when you're working on this kind of stuff, and it'll reduce the shaking. So we have that all cleared out. Let's see. Go ahead, and this is MG Chemicals No Clean Flex Paste. This stuff is great. These bottles should last forever because you're only using a drop at a time. This bottle has literally lasted me 6 months or so, and this is all I do all day, every day. That's all you need. Not a whole lot more than the size of the component you're working on. Touch IC will use a little bit more, and most components will use less than that. Turn the soldering iron a little bit. Turn your workpiece so you can get better access to what you're working on. some solder. This is just 6040 rosin core. Radio Shack brand. Good luck finding this. I bought 5 spools or so when Radio Shack was going out of business. The 6040 is great. If you can find some from Fry's or any electronic shop near you, or Amazon, this is 6040, 0.032 diameter, just some rosin core solder. Nothing special. Don't get the super thin stuff, don't get the thick stuff. I'm going to turn the air up by about 100 degrees. I was at 160 to remove the filler, or the underfill. I'm going up to about 270 to actually remove this component. My soldering iron is permanently set at about 428, 427. I like that area because I don't burn stuff too hot, and you'll cook stuff too cold and you'll tear pads. And I'm just going to point this away from the Wi-Fi and pray to God I don't brown out this Wi-Fi chip. And we'll go. It's tiny. I'm just going to leave the solder. It made nice little domes. If you use enough flux, then you won't have to worry about cleaning up the little pyramids. Add a little bit of flux. It stays okay. It made nice little domes. I still have flux left over. I'm not going to mess with it too much. I'm going to go ahead and steal the next part off my donor board, and I'll put it onto this one. This is a different board. Same thing. We're going to go to 160. Remove the black film. Add a little bit of solder. Bring it up to 270 and pluck it off. do once I've got this black film removed is to make sure that this is a good component. I didn't test it. There's about 1 in 1,000 likelihood that it's actually bad. I kind of doubt it, but we'll test it before, during, and after anyways, just to be certain. Even though this is a donor board, and we don't know how it's going to perform, what's wrong with it, I like to be careful with them because you never know what you need to steal. You might need Wi-Fi antenna, you might need the little components around it. You never know what you really need, so I'm careful about everything I work on. With the same component, I want to tear it off without destroying it. If you have resources, I would recommend buying a reel of this size, just because they're super common. And to that point, if you have the schematics, you may be able to see where another one is, maybe an easier one to steal. Good. I'm going to clean it a little bit, just so I can see what I'm working on. So, step one, solder paste. There's directions on that full plunger when done. That'll keep it from oozing out of the end. And we're going to clean soldering iron, add a drop of solder. Too much, clean it off a little bit. gonna go in here and add a little solder. This helps this component to melt before anything else on the board, and might get it off a little bit cleaner for you. And be careful not to overheat these capacitors. If you overheat it, there's a chance you could short it out. Not typically, but there's a chance. Okay. So we're going to go up to 270 with the heat. And wait for my little station to heat up, and then we will remove that guy. Again, if you're just tuning in, this is our donor board, and we're stealing a Wi-Fi common capacitor to put on a water damage phone, and hopefully that should fix it. After that, we'll be able to sort some other issues it might have and make for an interesting video. We're going to heat this up a little bit. So this is starting to change. You'll see it go from a matte color to shiny. Somewhere around that time it should let loose for you. For the love of God, don't yank on these. Give it all the time it needs. There it goes. And it looks like it came off in one piece. I'm going to release my donor board. This is my good board. And make sure you keep up with orientation. These are capacitors, and one side is ground, one side's not ground. And if you turn it backwards, it will either explode or do nothing. Hopefully it explodes. Those are fun. We're going to heat up this whole area. You don't want to put too much heat in one place too quickly. You could fracture the board, cause other stuff to go awry. I'm slowly going to bring the capacitor here into the picture. And my tweezers are too far up. That didn't go as planned. A little shaky. I don't know where you're at, but it's 7 o'clock in the afternoon here. And I'm usually best first thing in the morning. This isn't first thing in the morning. Try and come back in. Heat everything back up nice and slow. We want the capacitor and the board to be about the same temperature. And when we think we have it, we're going to set it right in place. And we're molten. It looks like the two have fused together. We're going to leave our tweezers nice and still. Move the heat away. Wait for it to solidify. And then we can let go. Normally I would add a little more heat to make sure that this is nice and flush. But again, with proximity to that Wi-Fi module, we really don't want to burn it out. I am going to clean this guy up a little bit. If you're going to get in trouble, now's where you're going to get in trouble. Overworking a board, saying, oh, let me do one more thing. This is usually where stuff gets messed up. A lot of times you'll have a working board, you'll have a positive result, and you go to replace one more thing, test one more component, let me just check this, and it goes badly. Add a little more solder. Make sure that you have it under flux. That keeps oxygen from getting in there. It gives you a nice shiny result. If you finish one of these and it looks porous, that means that you haven't added enough flux and oxygen got to the molten metal. Invaded that. It'll make it kind of spongy looking. Give that a few seconds to cool off. And we're going to come in with a good old isopropyl. At this point, if you did have an ultrasonic machine, you could use that. I think that's pretty clean. It's reworked, so it won't be perfect, but that's pretty close. What we're going to do is retest this capacitor, verify that we have resolved the short to ground. There's a few other ways you can do this. This board looked pretty cut dry. We'll find out though. It could be something else, shorting VCC Main to ground, but more than likely that resolved our issue. No beep. If I put these together, we do get a beep. So it's not shorting to ground. If we turn these the right way around, try it again. No beep. If we go to ground, it beeps. If we go to our VCC main line, there's no beep. I will reassemble and test, but I think that's resolved the issue on this phone. Pretty cut and dry. I'll be billing about half an hour, 37 minutes or so for this repair. I bill at a rate of about 150 an hour, so this would be approximately $75 repair. I don't charge for removing the board or finding out what's wrong with it. This one is pretty straightforward, so I'd be happy to work on this again in the future if it needed a screen or something like that. But if you have any questions or comments, please leave them below. If you had any questions or need a repair, let me know, and I'll be seeing you guys again in the future. Thank you.